From a single log, a new kind of forest is born, one engineered for strength and precision. This material is not merely pressed wood, but a symbol of engineering that unites strength with resource efficiency. Its creation begins as logs are peeled into thin veneer sheets. These are then dried, coated in adhesive, and stacked with the grain of each layer running perpendicular to the last. Under intense heat and high pressure, the layers fuse into a single board. This cross-grained structure yields an engineered wood that is both exceptionally strong and dimensionally stable. These qualities have made it a fundamental component in construction and furniture, helping to shape the face of modern architecture and interior design. It is a forest born not of nature, but of industry, a living factory cultivated for a single purpose, and its existence is the unseen foundation of the modern engineered wood industry. Where a natural ecosystem might take centuries to mature, these cultivated stands of acacia, eucalyptus, or pine are ready for harvest in a mere 7 to 20 years. Each hectare is densely populated with 2,000 to 3,000 trees, their planting carefully staggered by age to guarantee a constant, predictable supply. This model provides a crucial alternative, liberating the industry from its dependence on old-growth logging. Across the globe, these industrial plantations now span more than 290 million hectares. From this vast cultivated landscape comes over half of all the raw material needed for plywood production, a testament to the scale and efficiency of the system. The entire cycle is managed with scientific precision, beginning with seeds selectively bred to yield straight trunks and uniform grain. After nurturing in a nursery, the young trees are transplanted into plots, their spacing calculated to optimize land use while providing each one with an equal share of sunlight and soil nutrients. Throughout their growth, the trees are pruned, fertilized, and shielded from pests, a process designed to maximize the yield of every single cubic meter of wood. When the time comes, the harvest is swift and mechanized, as automated systems fell the trees, strip their branches, and segment the trunks into logs. The straightest, most uniform trunks are set aside, destined to be peeled into thin sheets of veneer. The tops and smaller branches are not wasted. They become biomass fuel, generating the energy that powers the very mills where the wood is processed. The ecological significance of this industrial model is profound. Without these managed forests, the global appetite for plywood alone would exert immense pressure on millions of hectares of natural wilderness, ecosystems that require centuries to heal. This closed-loop system, however, allows for rapid renewal, helps reduce carbon emissions, and acts as a buffer protecting vital wildlife habitats. In this way, every sheet of plywood becomes more than just a product of industry. It embodies a philosophy of balance, turning planting, harvesting, and regeneration into a sustainable cycle where economy and environment can work side by side. It arrives still breathing with the forest's moisture, but without care, that lifeblood can become its undoing. Once harvested, the timber arrives still holding the natural moisture of the forest within its fibers. But exposed to the elements, this same moisture can escape, causing the wood to dry out, crack, and lose its essential resilience. The log yard, therefore, is more than mere storage. It is a crucial resting place for the raw material. A fine mist constantly blankets the stacks, a system of artificial rain that maintains a stable humidity and prevents the wood from deforming as it waits. This gentle spray does more than dampen the surface. It works to equalize the moisture content between the dense core and the outer bark, a delicate balance that minimizes splitting and discourages the growth of fungi or insect infestation. Viewed from afar, the yard transforms into a sprawling reserve with thousands of trunks arranged in orderly layers, all under constant, meticulous watch. This careful preservation is vital, ensuring every log holds on to its innate quality. safeguarding the strength and stability needed for the next phase of its industrial journey. From this gentle cool, the logs move toward an intense heat. They are submerged into vast basins of hot water or sealed within steam chambers, where temperatures climb to between 80 and 100 degrees Celsius. The intense warmth penetrates the wood, softening its rigid structure and allowing the cellulose fibers to gently expand. This process relieves the immense internal stresses locked within the log, a critical step to prevent cracking. The duration of this thermal bath varies, lasting from several hours to a full day, depending on the wood species and diameter. Throughout this immersion, heat and steam work their way deep into the timber, reaching the very core to create a uniform consistency. When a log is finally lifted from the water, it has achieved a new state of flexibility and stability, perfectly prepared for the precision that awaits. A solid cylinder of wood spins into a blur, yet its unraveling is a matter of microscopic control. After being softened by intense heat, each log is sectioned into lengths ranging from 1 to 2.6 meters, a dimension dictated by the final panel size. Before the cut, a laser measuring system or a mechanical gauge scans the trunk, mapping the optimal length to maximize usable volume while trimming away major defects. The ends are then sawn perfectly flat and square, engineered to give the peeling lathe spindle a secure grip. Mounted securely, the entire log accelerates, reaching speeds of hundreds of revolutions per minute. The trunk becomes a giant wooden roll, ready to be unwound. A steel knife, stretching more than 3 meters long and sharpened to an angle between 20 and 23 degrees, presses firmly against the spinning surface. Opposite this blade, a nose bar applies steady counterpressure, compressing the wood fibers to prevent the veneer from cracking as it is peeled. With each full rotation, a thin layer of wood, only 1 to 3 millimeters thick, is sliced away, unrolling from the log as a continuous ribbon. The veneer's thickness is determined by the micro-adjusted distance between the knife and the spindle, combined with the speed of rotation. A deviation as small as 0.1 millimeters is enough to render an entire sheet unusable. Modern control systems integrate real-time thickness sensors, which send a continuous stream of data to processors that instantly fine-tune the blade's position. This ensures every sheet of veneer remains perfectly consistent, neither so thin that it tears, nor so thick that it resists pressing. When the log is reduced to a small core that can no longer be peeled, the long veneer ribbon is cut into standard panels and stacked. From a single solid trunk, a collection of flat, smooth, and uniform sheets emerges, the technical foundation for plywood's extraordinary strength. It begins as a fragile, waterlogged ribbon, easily torn, but through a trial of fire and air, it will gain unyielding strength. These freshly peeled sheets carry an immense burden of water, with moisture levels often surpassing 30%. In this state, the wood is soft, pliable, and susceptible to distortion. To forge stability into the fibers, the veneers are sent into vast drying chambers, tunnels that stretch for tens of meters and bathe the wood in superheated air ranging from 150 to 180 degrees Celsius. Carried along on conveyors, the thin sheets glide through a series of heating zones as powerful fans circulate the air, ensuring every surface is dried with absolute uniformity. In just 5 to 7 minutes, the internal moisture plummets to a mere 6 to 8%, the precise equilibrium needed to lock in mechanical strength without sacrificing flexibility. This process demands a delicate balance. Too much heat will cause the veneer to warp or crack, while too little will leave it damp and unstable. To navigate this fine line, a network of sensors constantly measures temperature and humidity, streaming data back to a central control room for immediate adjustments. At the end of the chamber, the veneers cool gradually in an enclosed space to prevent thermal shock, emerging as flat, stable sheets. With the wood now conditioned, it moves to a critical stage where adhesive will bind each layer into a single, powerful whole. The choice of resin is dictated by the plywood's final purpose. Urea formaldehyde is used for interior furniture, while durable phenol formaldehyde is reserved for outdoor applications that demand resistance to weather and moisture. Along the production line, each veneer sheet glides through a rolling or spraying system. This machinery applies a perfectly even film of resin, just a few dozen microns thick, enough to saturate the wood fibers with no excess left behind. Every variable, from the resin's viscosity and temperature to the exact volume applied, is meticulously controlled, as the slightest deviation could compromise the final bond. Optical sensors scan each sheet, monitoring the adhesive coverage in real time and triggering instant corrections for any inconsistencies. The result is a veneer with a flawless, uniform coating, perfectly prepared to be layered into the powerful composite structure that defines plywood's engineered strength. A delicate stack of wood becomes a single, unyielding form. The transformation begins not with heat, but with immense cold pressure. With their grains set at right angles and each surface coated in adhesive, the stacked veneers are guided into the jaws of a cold press. A hydraulic system exerts a steady, uniform force across the entire panel, reaching pressures between 0.8 and 1.2 megapascals. For 15 to 30 minutes, this pressure holds the assembly still, allowing the glue to spread evenly and tack the layers together, though the final chemical bond has yet to form. This crucial first step is all about stabilization, squeezing out trapped air and ensuring intimate contact between every single veneer. Without this stage, the adhesive could pool unevenly, creating weak points that might cause the panel to warp or peel apart over time. When the cycle concludes, the panel emerges in its preliminary shape, now solid enough to be carefully moved toward the next, more intense phase of its creation. From here, the stabilized veneers enter the hot press, a stage that will ultimately determine the final quality of the engineered wood. Inside, thick steel plates heat the panel's surface, maintaining a consistent temperature between 120 and 150 degrees Celsius. Simultaneously, hydraulic pressure increases, climbing to between 1.0 and 1.5 megapascals. This combination of intense heat and force triggers a profound chemical reaction. The resin liquefies, penetrating deep into the wood fibers before hardening, fusing the individual veneers into one monolithic block. Depending on the panel's thickness, this process takes anywhere from 4 to 7 minutes for each cycle to complete. All the while, sensors monitor the temperature and pressure, making constant adjustments to prevent overpressing, which could fracture the wood, or underpressing, which would result in a weak bond. As the press opens, the finished plywood sheet emerges, perfectly flat, smooth to the touch, and possessing a uniform thickness and high mechanical strength. This is the moment plywood is truly born as an engineered material, a composite that harnesses the strength of many layers, yet behaves as a single, solid whole. From the raw heat of the press, a new form emerges, but its journey from a rough-hewn slab to a finished panel is far from over. Once free from the intense pressure of the hot press, the oversized sheets are conveyed to the cutting station. Here, high-speed saws forged from alloy steel descend, trimming each panel to its final standard dimensions. These blades deliver impeccably clean edges, simultaneously shearing away any excess margins or imperfections created during the pressing phase. Every panel is meticulously aligned, ensuring absolute squareness and uniformity from one side to the next. The freshly cut panels then glide directly into a multi-roll sanding system. A series of drums coated in fine abrasives work in a continuous rhythm across the surface, methodically erasing any roughness to reveal a smooth, bright finish. Throughout this operation, a powerful dust extraction system captures airborne wood particles, maintaining a clean surface at every stage. This crucial finishing touch bestows each sheet with high geometric accuracy and a perfectly uniform texture. Before a panel can leave the production line, it must pass a final, swift inspection. Technicians scrutinize its thickness, flatness, and the integrity of its layer adhesion. Simple but effective tests, like bending or bond strength checks, are performed to guarantee that no sheet carries a hidden flaw and that every single one meets rigorous standards for use. Immediately following these tests, the approved panels are transferred to the packaging area. They are stacked into neat, orderly bundles, containing anywhere from several dozen to as many as 100 sheets each, and secured with steel straps or heavy-duty plastic bands. A protective layer of polyethylene film or durable craft paper is wrapped around every bundle, shielding the wood from moisture during transit. Labels detailing dimensions, production batch, and quality certifications are affixed. Finally, the completed bundles are lifted by forklifts and transported to the warehouse. This vast storage area is kept dry and well ventilated, with a stable temperature to preserve the wood's integrity. Arranged in immense orderly rows, the finished plywood now waits, ready for dispatch and distribution to the market. Where one process ends, another is born. In the shadow of the plywood line, nothing is truly discarded. The spent hearts of logs, ragged edge trimmings, and even defective veneers are all carefully collected. These remnants, along with small branches, are rerouted to the particleboard line, where they embark on an entirely new industrial journey. First, the wood residues are fed into powerful chippers, which shatter them into particles of varying sizes. The larger chips are reserved for the board's inner core layers, while the finer fragments are destined for its smooth surfaces. This raw particle mass then tumbles across vibrating screens. This mechanical sorting process sifts out any impurities, catching stray metals or oversized pieces before they can move forward. Next, the particles enter the drying chamber, a continuous blast of hot air heated between 150 and 180 degrees Celsius, reduces their moisture content to a mere 2 to 3%, the optimal level for bonding. The bone-dry particles are then blended with an industrial resin, most often a urea formaldehyde compound. A small amount of paraffin is also mixed in, an additive that provides crucial resistance to moisture in the finished product. On a moving conveyor, this sticky mixture is meticulously spread into multiple layers. Fine particles form the outer surfaces, while coarser ones are laid in the middle, creating the familiar three-layer structure of the mat. The entire particle mat is then loaded into a massive hot press. At temperatures around 180 to 200 degrees Celsius and pressures of several megapascals, the resin melts and penetrates deep, locking every chip into a solid, unified board. Once it leaves the press, the panel is cooled, trimmed to standard dimensions, and sanded perfectly smooth. The result is a flat, stable engineered material, more affordable than plywood, and suitable for a vast range of applications in furniture and construction. In this way, the factory operates on an almost closed-loop system. Plywood utilizes the high-quality sections of each log, while all the residues are reborn as particleboard, minimizing waste and extracting the maximum value from every single tree. From a single fragile seed, a material of immense strength is born. The journey spans from a nursery seedling to the towering trees of a managed forest, continuing through a precise choreography of harvesting, cutting, peeling, and drying. With gluing and immense pressure, the process culminates in a single, perfected sheet of plywood. Each thin veneer is laid with deliberate intent, every technical detail strictly governed to create an engineered material of exceptional strength and stability. It is a product capable of serving in everything from household furniture to the grandest architectural designs. Here, nothing is wasted. Even wood residues are reborn as particleboard, closing the life cycle of each tree within a truly sustainable model. This journey reveals that plywood is far more than laminated wood. It is a testament to human ingenuity and our enduring partnership with nature.